When we're solving simultaneous equations like that, it's nothing different from what we've learned last year, except now we have a quadratic and a linear, and we put them together. And so, of course, step one, we make each of these equations y the subjects, which it's done already. And step two, you make up some easy values of x, and then you plug them into each equations to find the corresponding y's. The 0 would usually be used because it's easy to calculate. Then we plot the graphs together, and of course we label each of the equations. And finally, you find the intersection points. In this case, it's this point and this point. Now, because we have a quadratic along with a linear, it's reasonable to have two solutions, right? Two answers. But when we have a quadratic and a linear put together, we could end up with one of these three situations. So if you combine these two together to form a big quadratic, then you can look at the delta or the discriminant of the big quadratic to see how many intersections there are without finding the actual solutions. So now let's consider this example. So we have a quadratic called C, it's right here on the graph. And we also have a straight line called L, which is not on the graph. L is a straight line, so it's a linear, passes through this point P and touches C at one point. So when it touches C at one point, it's automatically saying delta is equal to 0. But delta of which quadratic? Delta of C, this quadratic? No, it's actually the big quadratic that combines C with L, because we're talking about one intersection. So let's look at L first. So how do we find this equation in terms of M? Well, it's easy to find the equation of L because L passes through point P. And so here's the answer in the standard form. Okay, so this A, -1 for B, and this whole thing C. So part B, how do I find the values of M? Now I have C, I have L, I have two equations. I'm going to put them together and use this to help us to solve for M. So I combine them by substitution to arrive at this big quadratic in X. Now because C touches L, and touch actually means that there's only one point. And so delta of the big quadratic must equal 0. Then we put in b squared minus 4ac. Then with some simplification, now you've arrived at another quadratic here. Okay, and I call this secondary quadratic. Okay, because it's built on using this original big quadratic. And in this one, the variable is m, not x anymore. So don't get confused with the three different quadratic equations involved in this question. In the beginning, we have this quadratic for the C. Then we have this big quadratic by combining C with L. And then from here, we build on and we get this secondary quadratic, and it's in m, not in x anymore. So the answer is 4 or -4 for the slope. But finally, please also check the reasonableness of the answers in the context of the question. Sometimes you may have to reject, but in this case, we're fine.